Hey guys, welcome back. Now let's have a look over our temperature sensor, that is TMP112. And to have a better perspective regarding this sensor, what we're gonna do is to log in to the website, that is controleverything.com, and here we have to search for this sensor as you see on my screen. And let's see what we got for this sensor. And as far as I'm concerned, you see on my screen that it's a temperature sensor or with plus minus 0.5 degrees Celsius accuracy. This is the precision the sensor has, and also these are some more features which you are able to see on my screen. And at plus point, you can purchase the sensor right from here. That's correct. Furthermore, I will be interfacing the temperature sensor TMP112 with a BeagleBone Black, and the software platform will be a C code. Now to get your C code, let's go to resource tab, and here we have our C code sample. You can download the C code sample from this very own site as a zip file correctly, and after that you can also have the code from github.com and the concerned repository. There will be control everything community. Now let's have a look over the hardware connections we need to put up together, and let's see what we got there. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Now this here is our temperature sensor TMP112, and this here is a connecting cable. Now make the connection among the cable and the sensor, and make sure that the ground terminal of the sensor should be connected to the ground wire of the cable, and similarly to the ground of I2C Shield. Now we are done with all the hardware connections we need. Now what we're gonna do is to have a look over the code. Now let's have a look over the interfacing part, and to get there we have to first of all log in to github.com, and after that we have to search on for the repository which is onto the screen, that is control everything community, which you are able to see on my screen. And after getting that, we have this sensor, that is TMP112, and this here is the C code. But before that, let's have a look over the concerned instructions we need to fulfill. First of all, we need to set up our BeagleBone Black, and the beaglebone.org is the relevant link from where you need to install this software, this entire BeagleBone, and you can see the relevant drivers and software. Please do it carefully. And after getting this, we have to download or pull the code onto the BeagleBone Black, and this command will help us to compile, and this will build or run the C code. Note it down, which we will use later in the working part. Now get to the C code. It's a .c file as you notice, and first thing you notice into our code that we have included some of the header files, some libraries here, and in the void main function you see we have created an integer, and then we have created a function which will check whether the I2C bus is open or not, and after that we have to check what I2C device is connected and whether the address of the sensor, that is 0x48 or not. Now coming to the writing section part, first of all we need to select the configuration register having address 0x01. It's a 16-bit address register as you know, and after that we are going to send a command for continuous conversion mode. 12-bit resolution fault queue is 1, that will be 0x60, and polarity loop thermostat in comparator mode disables shutdown mode, that will be 0x80. And here we are sending these commands as you know, writing command here. After that we are going in a sleep or delay of 1 second, and then we are going to read some data. As you know, we are going to read 2 bytes of the data from the register 0x00, and this is the command for that. And after that we have a conversion formula for the temperature which we have seen in the data sheet for TMP112. At the end of the code, we have output to be displayed onto the screen, which you can see as the temperature in 2 scales, that is Celsius and Fahrenheit. So this is how a simple and generalized code is there onto the screen. Now what we're gonna do is to look over the working and let's see what we got there. Now let's have a look over a very interesting part, which is to show the practicality, and for that part we need to copy the entire code just like that, and we have to go to BeagleBone.org and we have to connect it, and here we have to create a new file. .c will be the extension, and we have to paste the entire code here, and after that we need to save it. Then the command is there for the compilation, as you can see on my screen. It's a .c file, and here we go, and let's see what we got here. And the code has been compiled successfully. Now to build our code, this is the command, and when I run it, we have the temperature in Celsius and Fahrenheit, and it's there. It's almost constant because there is no interference regarding the temperature right now. But when I try to fix my finger over the sensor and place it and I run the command, there is a significant change in temperature in both the scales, Celsius and Fahrenheit. When I again run the command, still my finger over the sensor, you can see the changes is there. So this is how the sensor responds. Now let's have a look over the applications and some of the benefits of this particular sensor. The TMP112 device is a digital temperature sensor ideal for anti-C PTC thermistor replacement where high accuracy is required. The device offers an accuracy of plus/minus 0.5 degrees Celsius without requiring calibration or external component signal conditioning. The TMP112 is ideal for extended temperature measurement in applications like portable and battery-powered applications, power supply temperature monitoring, notebook computers, battery management, thermostat controls, electromechanical device temperatures, and a lot more to mention. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubts regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com. And to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.